Hello, always you are welcome. These sessions by MFAB Training Solutions. So today I'll be basically discussing about the alligation method. Always remain Wilson, your presenter. So what is alligation? In most of our calculations, we have this method called alligation, which is used in dilation or is also in concentration. And alligation is a method. It is a simple illustrative method in pharmacy used to calculate the proportions of any two or more solutions or products or ingredients possessing different strength, or a pure product or a product with no active ingredient, which are supposed to be mixed together to prepare a final solution or product of the required solution. So in this method, you are having unlike dilutions where we are diluting a product, here we're having two or more products which are having concentration, and you're trying to mix them together to prepare a final product of the required strength. And most of these ones could have a concentration, or sometimes you could have uh, an excipient having no concentration, and that becomes a dilution in alligation. So alligation enables pharmacy professionals, even other professionals, to quickly estimate the ratio and then prepare solutions of the desired concentrations from the available stock solution. As shall be seeing in the examples and also in the quizzes and questions which have been prepared, how these questions come in, that you're having two products and you want to prepare another product. So how do you mix them? Which ratios do you combine? So there are two methods in alligation, alligation media and alligation alternate. So in this presentation, we shall only focus on the alligation medial calculations. Now, what are these calculations in alligation medial? Of course, this is used to calculate the total percentage strength when two or more components of known concentration and volume or weight are to be mixed together. So in this one, you're having 2 grams of sulfur ointment and maybe 5 grams of sulfur ointment of different concentration, which are supposed to be mixed together. So what will be the final concentration of the mixture? So that is what we call alligation. This method involves getting the total amount of the active ingredient in the solutions or products to be mixed together, and then dividing with the total volume or quantity of the products, and then you multiply by 100 to convert to a percentage. All this one has been explained in the next slide, what it means. So remember, in alligation media, we are multiplying, or we are having concentrations of products of known concentration and quantity. So multiply the concentration or specific gravity with the quantity of each product or solution to get the total active ingredient. So I'm going to show you the next slide how to do it. Of course, if you're having two or more products, you just say uh, uh, percent, maybe 2 out of 100 times the volume or the quantity. Add to get the total active drug in solution or the product. Now here, if you're having 2 or more products, you do the same for all the products. Then you add, you get the total. Now, also, we get the total quantity of the solution to be mixed. This one may be provided if the formula has the word 2, or sometimes we need to add the 2 or the 3 or 4 products or solutions to get the total quantity. So now the new concentration of the mixture is just the total of the active drug in the mixture divided by the total quantity of the products mixed. Then you multiply by 100. As we agreed before, we don't say 100%. The percent goes on the answer. So if we use specific gravity, total after multiplying with specific gravity over total quantity of the products mixed, as we're going to see the examples. So this procedure is important and is understandable. One, you multiply the percentage concentration or specific gravity with the quantity of each, then to get the active to active in each product. You do it for 2 or more products. You add to get to active in the solutions or the product to be mixed. You add the solutions, the quantity of the solutions which are supposed to be mixed, and then you follow up with these 2 equations. Now, if a solution contains no active ingredient, the concentration is 0. This one we have looked at this one over and over. Attention should be given to words like to, add to, which may require to subtract from the total volume or quantity to get that, to get total amount. This one we have also seen it before. For example, if they said that as we are having maybe water to this one and add other products, as we are going to see next calculations, how do you get quantity of water? I have an example here. One example, for example, I have what's the concentration of sulfur in a mixture prepared by mixing three different products. Let us call this one 3 different products. 50% of 50 grams of 10% weight per volume sulfur ointment. Products of sulfur. Let me make it clear like that, of sulfur ointment. So I'm having all these products having the sulfur. This is the strength of sulfur, the strength of sulfur, and the strength of sulfur. So remember we said procedure 1, get the quantity of the active. So even you can just write them there. The quantity of sulfur in a product. You can illustrate it like that, will be easier for us to get. So it's always important you tell us for which one you are calculating for. So for the one of 10% weight per weight, just 10 out of 100 times 50, you get that. One of 20%, the same, you get that. And the one of is supposed to be 5. And one of 5, you get that, get 15. So you said we get the total quantity of the active, which is sulfur. So total sulfur is 5 plus this, you get 26.5. Now you also need to tell us the total quantity of the product, which is just 50, this 50 plus this plus the 30, and then you get that answer. So the new concentration is just the quantity of the sulfur, which is 26.5 grams, divided by total weight 18 grams times 100. Then your answer has a percent weight in weight. Ensure you transfer all this information on sulfur. So after mixing these products above, the total concentration of the mixture would be 14.7 weight per weight sulfur. Now, I have an example 2 here. Find the percent concentration of the ether of alcohol in the formula. Our product A, 60 volume, which contains 70% ethanol. Product B, then this. Then also I have purified water to 250 mils. Now, the final volume, it is, if this one is having the word 2. This is how I'll attempt this one. So the concentration of purified water, we know it is always 0. However, I also need to calculate the volume of water, which is just 250 mils minus these two, because the solutions or the product contains 3. If I'm having the quantity of the 2, the other remaining volume is 4, the third one. So now, how shall we proceed? Remember, we said first get the quantity of the active drug. Here, the quantity of drug is ethanol. So in product A, it is always important to tell us what you are calculating for, so that even you yourself, you can follow what you are calculating. It was 70% out of 100 times the volume was 60. So this is the ethanol there. Product B, it was 25 out of 100 times 120. This is the ethanol there. And also calculate for purified water. Don't forget it, which is 0 out of 100 times 70. We're getting 0 means ethanol. So the total quantity of ethanol is that 75 mils, and the new concentration is 75 out of 250 times 100, giving 30%. Give us units. Okay? Volume per volume of ethanol. So I have another question, which is for specific gravity. They're asking us to what is the specific gravity of a mixture prepared by mixing 50 mils of volume A with specific gravity of 1.3 and 20 mils of C with specific gravity of 0.95. So this has to be C, sorry. So now the quantity, or here we are looking at not the quantity of the active in A. Sorry about that. In A is the specific gravity 1.3 times 50, 0.93 times this one for C, and you get this. Now the total quantity of the active in these two is 65 plus this, giving 85. Total volume to be mixed, you need to show us how you've gotten them. It is the 50 plus 20. Now the new specific gravity is just total, this one, the 85 over total volume mixed, giving me 1.2. This has been an illustrative presentation, and as always, we are having more questions in our Google Classroom app. So follow up and try to attempt them. I'll be there for